Welcome to the fourth hole of the Adventure Golf unit. Today we will be studying special types of triangles. Change from your study of triangles in the past, where you've named triangles as either right triangles, acute triangles, obtuse triangles, or isosceles triangles, equilateral triangles, or scalene triangles. My expectation will be that you will now name these with both angle measures and side lengths at the same time. So instead of something just being a right triangle, it may be a right isosceles triangle or a right scalene triangle. By definition, a right triangle has one right angle or one 90-degree angle. An acute triangle has all three angles are acute, and an obtuse triangle has one obtuse angle and then two acute angles. And again, we're putting all of these names together. A scalene has three different side lengths, an isosceles has two different side lengths, and an equilateral has all three sides the same. And you can see how these tick marks are used. This has one tick mark. There's nothing else that has one tick mark, which tells you that all three are different sides or different lengths, because this has one, this has two, this has three. Whereas an isosceles, this leg and this leg each have one tick mark. Because they both have the same number of tick marks, that indicates that these two sides are congruent. And then down on the equilateral, all three sides each have one tick mark, which tells you that the three sides are all congruent to each other. If we are classifying these triangles with both side length and angle name, starting off, the first triangle that I see here has two sides that have one tick mark. So that tells you that this is an isosceles triangle. And I look at that, there are no right angles, there are no obtuse angles, which means all three are acute. This is an acute isosceles triangle. If I look at my next triangle, I have one tick mark on each of the three sides, which tells you all three sides are congruent. If the three sides are congruent, the three angles are also congruent. And they are all acute. This is an acute equilateral. Triangle. And my final triangle on the top here, I can see I've got one angle that's greater than 90 degrees, which tells you it is obtuse. And it appears that all three sides are different lengths, which means that this is an obtuse scalene triangle. Sorry, there's no C there. When I come down to the bottom, my triangles actually have angle measures given. And what this is telling us is that all three of these angles are different. And when you have different angle measures, the side lengths are all different as well. So the smaller the angle, the shorter the side length. That is opposite. So the 27-degree angle, this side length would be opposite. It's the shortest. The 35 is the next biggest angle. This side is the next longest. And then 118 and the hypotenuse is opposite of the biggest angle. So these are obtuse because there's one obtuse angle, and it's an obtuse scalene. Down here, this fifth example, I've got a 90-degree angle, which tells you that it's right. And this angle and this angle are different. And because my angle measures are different, it tells you my side lengths are different. So all three side lengths are different, creating a scalene. So this is a right scalene triangle. And then finally, the last one, all three angles are acute. All three angles have different measures, which means all three side lengths are different. This is an acute scalene. You should also notice in these examples that the sum of my angle measures in each example is 180 degrees. And that's true for all triangles. What you should have seen on the last slide, there are special relationships that exist in triangles. If there are three different side lengths, there are three different angles. If two sides have the same length, then there will be two angles that are congruent to each other. And if all three sides the same length, all angles are congruent. The opposite way of looking at the same concept is if all the angles are different, all the sides are different, which means it's scalene. If I have two angles that are the same, then I will have two sides congruent. And if all three angles are the same, all sides are the same. Using the idea that there are 180 degrees in a triangle, and being able to look at the markings on this triangle and seeing that I've got two sides are the same, that tells me that two of my angles are the same. And I can visually look at this and see that this angle is congruent to this angle. If I know there's 180 degrees in this triangle, and I've already used up 30 for this smallest acute angle, that tells me I've got 150 degrees left. And if these two angles are congruent to each other, I have to split that 150 in half, and I know that each angle is half of 150. Each of these angles would be 75 degrees. And I can tell that because I understand the tick marks mean these two sides are the same, and if the two sides are the same, these two angles are the same. The last thing we're going to look at during this video is how you can find the third side length of a triangle, or the range in which the third side length must fall. In class we talked about if point A is 3 miles from point B, and I know that point C is 5 miles from point B, and I'm going to create a triangle. How long is that last side? If this 5-mile side goes out in the same direction as A, that would be 2 miles. However, if that goes in this opposite direction, and C is over here, A to C is now 8 miles. So if it's somewhere in between, this won't actually allow me to move the endpoint. But if that 5-mile line goes up like this, the hypotenuse of my triangle now must be shorter than 8, and it must be longer than 2. So essentially, if my lengths were 5 and 3, it must be less than 8, but greater than 2. So the third leg of a triangle must be greater than the difference between the other two legs, but smaller than the sum of the other two legs, which can be seen here. You're now ready to get online and print out the fourth hole scorecard.